Hello everyone. Welcome to reInvent 2020 session on how to efficiently architect IoT applications to optimize your returns on investment. I'm Aditi Gupta, your host for today. I'm an IoT specialist solutions architect at Amazon Web Services. Let's have a look at what you're going to get out of this session. First, we are going to talk about the best practices on how to lower your AWS bill because this is what you're here for. The same best practices can help you build a more scalable, more robust, and more dynamic architecture, so it's actually a win-win. Here, you will also learn how to save time to innovate, because time is more valuable than money. I'm not going to just talk through us about some theory, but I'll bring you some real-world examples on how the customers have reduced their IoT spend by 95%. Finally, all these are easy to implement. So when you walk out of this session, think about how you can put these into practice today, tomorrow, or next week. Now let me present an interesting fact. That is, even if you don't do anything, we are working hard to save your money. This is possible because of the AWS business model. It's really based on using this AWS flywheel. Reduced prices bring more customers, which bring more economies of scale, and then there are two accelerators in this model. The first is the infrastructure innovation, to be faster and be more efficient. The other accelerator is that the increased usage keeps the community of users and partners growing, bringing us feedback to build new features and services and making it more attractive to you, our customers, over time. We bring this back to you in form of further price reduction. Since 2006, we have been able to reduce prices more than 80 times, and we are nowhere close to done. Talking about price reductions across AWS, I wanted to take a moment to highlight the most recent price reductions in Amazon IoT services. And these are especially in the past 1 year or so. So also, as we all know, IoT applications are not just about the IoT services. They include services like AWS Lambda, Amazon Kinesis, Amazon S3, and many more. So I urge you to go back and check the recent price reductions and see the impact on your IoT workload. On AWS, your biggest strength is the architect, is as an architect and as a builder is the architectural flexibility. So you can always go and change and optimize your architecture. This could be a continuous process which gives you the agility that people expect from the cloud. And it's okay to start with the minimum viable architecture, see if it works, and then you can start iterating and try to get rid of the unnecessary or idling resources or make changes to do things more efficiently here. Like in AWS, like the AWS flywheel, as you go about improving your architecture on AWS, there's also cost optimization process, which basically always starts with measuring your current cost on AWS. After getting transparency about your cost of IoT application, you can then start coming up with ideas on how to build a better architecture. And once you have those ideas on paper, you can start building them for real in the cloud. The first step is always to measure your existing cost, so you know where you're standing, and then you can plot a course to where you want to be. The best way to start that is by using the AWS Billing and Cost Management dashboard. You should be very familiar with this dashboard because here you get a complete picture of all your cost breakdown in any foreseeable dimension. Now you might ask me that, hey Aditi, this gives me a good view of one account. However, I'm a solution provider operating in environments such as smart buildings, manufacturing systems, connected products, etc. So these are often deployed in multi-tenant deployments. How do I easily manage and build those? And this is where I would like to explain the use of AWS tags and IoT billing groups to solve the problem. Let me explain this a bit more in detail. So let's start with this cost management consoles, Cost Explorer, and the terminologies. Tags. Tags, as we know, allow the grouping of cost from various AWS services like IoT Core, S3 buckets, Lambda functions, etc., which are consumed in a particular context. Billing groups are created to collect billable information for the member things. For example, by using the billing groups, you can group the versions of your products. So you can do the analysis on how your new version may impact your cost. And you can do things like break out your cost structures across different types of devices. You can tag each billing group that you create to identify which tenant, business unit, product, projects, or in fact any dimension are things being used for. When you apply tags to billing groups, AWS generates a cost allocation report as a comma separated value file, the CSV file, with your usage, and the costs are aggregated by your tags. The IoT billing groups come with APIs to create, list, delete, add things, etc. to the billing groups. The Cost Explorer also comes with an API that you can integrate with your monitoring system so that you can get a near real-time feed of your costs on AWS. And you should also now be ready to define your tagging strategy to improve the measurement of your overall IoT workload. Now, before I move on, I want to quickly recommend to always set up a budget in the cost and billing dashboard for the next few weeks or months and get a better planning. The budget function will send you automated notifications like emails when you're reaching certain milestones. And this gives you full cost transparency, avoiding any surprises at the month end. Let us now look at some of the cost optimization patterns, bringing you the learnings from our experience with various customers and partners. Now here I want to start with the cost calculation for a customer example, where I'm going to show you the cost impact of simple decisions at scale. The customer here has devices with multiple sensors on it. The use case is relevant for any devices, from office like printers to industrial equipment to wind turbines, any device with multiple sensors generating data at different pace. Now, this customer wanted to create a device monitoring system for about 100 devices, and each device had multiple sensors. The setup has devices or data sources connected to AWS IoT Core. So a small function is run for each incoming message using Lambda. The Lambda further routes the data to other AWS services such as S3, DynamoDB, or Kinesis, whatever the application requirements are. This is what I have not represented here in the diagram. But like many customers, this customer also wanted to get the data as soon as it was available. So each device was sending 10 messages per second. The average payload was about 150 bytes. And if you look at it, this was a sample, this can be considered as a sample JSON packet from the device. Of course, it's not the real one, but just a sample there. Now, once the data reaches AWS IoT Core, each message is triggered one rule with one action. As a quick recap, the rules engines in IoT Core allows you to transform the data using arithmetic operations or external functions such as AWS Lambda. Rule engine use is metered for each time a rule is triggered, and for the number of actions executed within the rule. So as you noticed, we had one action for this rule. So in this particular case, there was one action per rule, which basically routed messages to Lambda. If you look at my calculations, look at the number of messages, which is also equal to the number of Lambda calls per month. Now, these number of invocations were testing AWS service account limits. Summarizing for cost, With just 100 devices, the total cost of AWS IoT Core and Lambda was more than 62,000 US dollars. Now, this looks prohibitive. And I have not even presented the downstream cost here for you guys. And if at this point you're feeling that AWS IoT is way too costly, then please hold on and please pay attention to the next few slides really carefully. Let me explain that. Now, knowing what we know about the pricing, we could clearly see that the customer was not making the full use of IoT message sizes. You see, the MQTT payload size is a critical cost optimization element for AWS IoT Core. An IoT message is built in 5 KB increments. For this reason, each MQTT payload size should be as close to 5 KB as possible. For example, a payload that is currently sized at 6 KB is not as cost efficient as a payload that is 10 KB because the overall cost of publishing the 6 KB message is identical to the 10 KB message despite the message being larger than the other. Now, we sat with the customer in this case to try and understand and explain how batching can be used. The customer shared that the critical component generates data only once in 2 seconds. This decision, the decision was taken to batch the messages and bring down the frequency of the data to 1 batched message per 2 seconds based on the critical component. Now, the packed payload started looking something on the lines of the sample here. The message size now grew to 3 KB from 150 bytes. Even though the message size was still not close to the desired 5 KB mark, it was still the right balance between the required critical components monitoring frequency and the effort needed to implement the change. Now, in cloud at AWS IoT Core, the IoT rules remain the same. We still had only 1 rule per message. Only this time it was a packed message. The second difference came from the introduction of the Amazon Kinesis data streams. Not only does Kinesis data stream increase the durability of the message, it also batches the data together automatically. So the packed payload was further reduced, and the sample output from Kinesis looked something like the sample shown. So if you notice, with 2 layers of packing done here, the number of Lambda calls should reduce dramatically. As it is now 1 per Kinesis message, and let's see how this impact the simple. Now let's see the impact of these simple changes here. On the left is the old cost for the unoptimized, and right is the optimized cost. And as you can see, the annual cost has fallen dramatically for the 100 devices. This again has an impact on the downstream services as the usage cost. Although I must add that this approach has trade-offs, and that should be considered before implementation. Before adding complexity or delays in your devices, you may want to check whether it has any impact on the processing cost. The example that I presented didn't have much. Again, we heard you. Seeing the significance and impact of this pattern for our customers, we have launched new features in the IoT rules during this reInvent. The IoT rules engine now supports batching and debatching, especially for Amazon Sitewise, in the form of new capabilities. So not just for Sitewise, but yeah, for others as well. So as a quick recap, IoT Sitewise is a managed service that makes it easy to collect, store, organize, and monitor data from industrial equipment at scale to help you make better data-driven decisions. So it's good for Sitewise, but at the same time, in terms of new capabilities, the customers were also now using the free, customers are now able to use the new free transform inline function to transform the Amazon Sitewise or other batched payloads before sending it to Firehose or IoT events and IoT analytics via the actions in the batch mode. I would urge you to go and check more information on these features. In the previous example, you saw the power of optimizing the MQTT payload size. Similarly, let us expand this to device shadow, which is the virtual representation of your device in the cloud. Your device should only send this full device state if your firmware logic dictates that your full device state may be out of sync and would be best reconciled by sending all the current settings. As individual state changes occur, the device should optimize the frequency it transmits those changes to the cloud. For example, for the shadow, you could aggregate several reported fields together into one shadow message update instead of sending each reported change independently. And grouping shadow updates together may work to reduce the overall cost of the shadow by consolidating updates to the service. At the same time, IoT devices often have multiple state data such as user settings, manufacturer configurations, and operational status. Each of these state data needs to be accessed by different users or at different frequencies. As you grow shadow usage, look at using the sub-shadows or named shadows, as we also call them, to separate the logical device boundaries and decrease the size of your shadow overall. The named shadow allows you to create multiple shadows for a single IoT device. This helps you to store different device state data into different shadows. And as a result, only is required state data when needed and reduce individual shadow size without running into the problem like accessing entire shadow or shadow size limit prematurely. A good example here would be a vehicle. A classic shadow document can contain two subshadows in JSON, one for the motor of the vehicle and one for the infotainment for the car. And as we know, these are updated at different frequencies. So the optimization we can do is to use the named shadows and update them at different frequencies. So you see there are two different patterns that we are using here with shadows. Now taking the device monitoring example further, do you think that we needed all the data being collected was actually being needed? I mean, in most cases when we ask the customers, what do you do with this data? Most customers, often say, just in case we need it in future. Now, this has huge cost implications. A lot of time series data, control data is just ignored. One of our customers made optimal use of our edge capabilities to reduce the cost considerably. As we know, IoT Greengrass allows you to run MQTT local routing between devices, data caching, AWS IoT Shadow Sync, local AWS Lambda functions, and machine learning algorithms. Now, using this, the customer used the Lambda in Greengrass to calculate summary parameters at edge and discard the raw data, thus saving huge cost in data transmission and ingestion. To ensure that they didn't miss out any crucial data points, they used IoT device shadows to manage the log level at edge in case the error was detected. In one of their recent deployments, the customer has further enhanced their devices by deploying the machine learning model at the edge in tiny microcontroller units. Now again, some of you might ask, but I do have the need to send data streams. How can I manage these high volume data streams at the edge? Your answer lies in the Greengrass Stream Manager. Stream Manager allows you to do things like aggregation, sampling, discarding duplicates, etc. before sending the data to the cloud. Let's see how the Stream Manager works with a practical use case. For example, my AWS IoT Greengrass core device is receiving lots of data from multiple devices. I want to do two things with the data I'm collecting here. One, upload all the raw data with low priority to AWS IoT Analytics, where I use Amazon QuickSight to visualize and understand my data. And second, to aggregate the data locally based on the time and location of the devices, and send the aggregated data with high priority to Kinesis data stream that is processed by business applications for predictive maintenance, say. Now, using the Stream Manager in Greengrass Core SDK, I can create two local data streams. The first local data stream can have a configured low priority export to IoT analytics and can use up to, say, 256 MB of local disk. Yes, it is a constrained device. You can use memory to store the local data stream if you prefer speed to resilience. When local space is filled up because of, say, I lost connectivity to the cloud and I continue to cache locally, I can choose to either reject the new data or overwrite the oldest data. The second data stream is exporting data with high priority to Kinesis data streams and can use up to 128 MB of local disk. Now it is aggregated data. I need less space for the same amount of time and same amount of work. Notice how this solution has two ingestion paths, the IoT analytics and Kinesis data streams. Next, we take a deeper look at selecting the right ingestion service for particular workloads. Here I present to you the possible strategies of managing ingestion and processing a throughput of IoT data to other applications. In a well-architected IoT application, internal processing systems are decoupled from the connectivity layer of the IoT platform through the ingestion layer. We encourage you to use the right AWS service for ingesting the data. Here are some of the ingestion options that we can consider. Basic Ingest optimizes the data flow for high-volume data ingestion workloads by removing the publish-subscribe message broker from the ingestion path. As a result, customers now have a more cost-effective option to send device data to other AWS services while continuing to benefit from all the security and data processing features of AWS IoT Core. When dealing with raw data from batch pipeline, you can use AWS IoT Analytics and Amazon Kinesis data stream or Kinesis data firehose to transfer the data to S3 buckets and Amazon Redshift. Moving on, log files should be published directly to S3. Imagine a 128 KB log file going through IoT Core. This would result in 26 MQTT messages, and add the cost of IoT rules to it, you get a huge number there. Compare it with the cost of one put call to S3. There is a huge saving. And further, to lower the cost in S3, Amazon S3, an application can leverage the lifecycle policies from the storage that can archive data to lower cost storage such as Amazon S3 Glacier. Let's take another example of gas turbines video monitoring. Here, the video camera feed can be ingested by Kinesis video streams. Load telemetry command and control can be taken care of by IoT Core. So you can use Kinesis video streams as your data plane, whereas your IoT Core as your command and control plane. Extending the same learnings of choosing the right database based on the velocity and purpose is always a good decision. Okay. Talking of the build, it is often a question on how to decide whether to build your solution or use services managed by AWS. I would like to touch this pillar from the point of optimizing your returns on your investments. Let us again take an example of one of our customers, which is into energy generation and monitoring. They chose to build their own custom data ingest on EC2 using open source Kafka. The customer is now struggling to manage all of the day 2 operational aspects of their open source workload on EC2. Aspects like graceful upgrade, applying security patches, build automation, run this automated low-touch, self-healing way, etc. These are typical day-to-day problems that we see. In contrast, it would have been possible to connect these devices to IoT core without worrying about the horizontal scaling of the services as your fleet grows. No managing of physical services or disk space. AWS also provides services that bring more vertical integration of features as application level services. These services aim to fully solve problems or deliver an outcome that can be used on its own, abstracting away even more undifferentiated heavy lifting for our customers. Back to the customer example. By engaging the AWS professional services, they tried to overcome some of these challenges. But the customer found that there are significant shortcomings in their approach. When self-implementing, the customer painfully became aware of the pace of innovation at Amazon. When we're building and releasing new features for our customers at the speed we do, and customer is stuck in undifferentiated heavy lifting in area which is not even their core expertise. The customer also realized how the open source HiveMQ or Kafka ingest layer does not encompass nearly as many features as we do with the AWS IoT services, let alone how many we are going to implement in future. Now, looking at the total cost ownership, which was the original point of this decision from the customer found that the total cost of ownership for self-implemented solution had additional components of professional services and then additional licenses and support added. Whereas if AWS Managed Services were there, it would help to future-proof the system and bring additional benefits as well. I would say that what one needs to do is focus on the return on investment. The ROI benefits of AWS Managed Services come not only from the excellent pace of innovation, but also by saving your time. Time is more valuable than money. Now, instead of focusing on the undifferentiated heavy lifting, you have more time to go and create more application features that help you generate more revenue and your saved on your effort of the team. Now, there are a few more higher order managed services that I want to quickly highlight to you today. IoT Analytics is a service to store, process, and query IoT data at scale. It solves the problem of scaling up in ingestion endpoints of your fleet and performing ETL on your payloads as they arrive, storing raw and processed or cold data, and giving you simple mechanisms for querying and operating on your data. Check it out. The next service that I want to bring is the IoT Events. Now, IoT Events is a service for building serverless applications for complex event detection. You define a detector model in terms of inputs, states, transitions, and actions, and then deploy your model to the cloud. IoT Events will scale up the instances of your detector model for each of your devices effortlessly. You can craft a surprising amount of application logic in IoT Events without ever writing or deploying a line of code. AWS IoT Device Advisor is a new service, which is a cloud-based, fully managed service to test the compatibility of IoT devices connecting to AWS IoT Core. Device manufacturers can test their IoT devices with over 20 pre-built tests for reliable and secure connectivity and the ability to remotely receive updates, all without building any test infrastructure of their own, while reducing the development time and cost and increasing test coverage. It is up to you to evaluate how fast you want to bring these solutions to life. Managed services are here to help and focus your time on solving real problems, not the challenges of developing a scalable distributed system. As we come towards the end of the session, let's see what we can do once you leave the session. Here are some of the suggestions. Now, we love you as customers. but we want you to run your workload at as minimal cost to you, and that's where I recommend that measure your spend, and spend as less money as possible. Now, to learn more about calculating and understanding the ROI of IoT, check out the reInvent session IoT 204. The next section that I recommend is about the AWS Well-Architected Framework, which I'm sure you're aware of. The framework helps you, the cloud architects, to follow a consistent approach for customers and partners to evaluate the architecture and implement designs that can scale over time. It includes domain-specific lenses, which in our case is the IoT Lens. The IoT Lens document covers common IoT scenarios and identifies key elements to ensure that your workloads are architected according to the best practices based on the same five pillars, namely operational excellence, security, reliability, performance efficiency, and cost optimization. Go have a look. And finally, as we come towards the end of this session, I want to ask you, which of these strategies are you applying today? Which of these are missing in your architecture? Go explore. Thank you. I'm your host Aditi Gupta, signing off for today. Happy savings.